Everyone's been talking about this new model Inkling released by Thinking Machines Lab. So, Thinking Machines Lab is a research based company started by Meera Murati, the ex CTO of OpenAI. They've also been releasing various interesting research regarding LLMs like determinism and manifold research. And now they've released their own foundational model, and it's called Inkling. The most significant thing about this is that it is open weights in the sense that the weights are available on Hugging Face and you can customize it as per your needs. And if you have the infrastructure, you can also deploy it on your own premises. And just to clarify, I am not associated with Thinking Machines Lab. They are not sponsoring this video. I just cover topics regarding AI and new model releases and also for fine tuning and customizing AI models using various options like fine tuning, RAG, and also using synthetic data. So, this is again a significant step in terms of open source AI because a model that is this large and this capable is being available for customization. And usually, when we think of open source, it's mostly the Chinese labs like DeepSeek, Quen, and now Moonshot AI. But I think this is one of the companies that is supporting open source from the US because the other companies, like we all already know, that they're more closed source. Llama family models were the only models that were in this open source space. But it's great that Thinking Machines is also now joining this open source movement. So their model, it's called Inkling, and it's a mixture of experts transformer with 975 billion parameters, but only for 41 billion are active. It's still a huge model, but with mixture of experts architecture, only a part of the parameters will be active. And they say they also support a context window of up to 1 million tokens, and it was pre-trained again on publicly available data with like 45 trillion tokens of text, images, audio, and video. And there is also a lighter version of this with 12 billion parameters, which is not huge, so it can be easily customized. But yeah, so there are there are two versions of it available. Yeah, so it is multi-modal, which means it also supports text, images, and audio. And also mentioning that they will continue to build on this, which means that we can expect more models or with maybe bigger capabilities. And the main distinctive feature of this is the customizability, like I said. So, thinking machines, if you see right from the beginning, their objective is to work more on the training and fine tuning space instead of releasing their frontier models. In fact, I was a little surprised that they are going in this direction, but I think it's great because we now have one more open source option. But their focus has always been on fine tuning and making fine tuning easier and also making the infrastructure more available because if you want to fine tune a huge model with very high capability on your own, you will need a lot of infrastructure. But I think if you use this Tinker API, their API is called Tinker. If you use it makes it much easier for you to train because you have to add some credits like how you add credits for OpenAI, and then it will and then you can use some code which is available on their GitHub, and then you can customize many models. They've also teamed up with NVIDIA, so this it also includes Nematron models as well. So in this example on their blog itself, they have given this example where they just ask the model to fine tune itself. So they give it a small task. So what the model does is it generates some data by itself. It will create a fine tuning job, and then it will fine tune the model, and then also switch to that model, and then use it to provide the whatever response that you need. So you can go through this example, which is quite interesting because I think the direction of AI is going towards this self improving AI, where the AI models can just improve themselves or fine tune themselves on the fly instead of you writing a script and then running it. The capabilities, it's very similar to what models we have in the market. This is very generalistic, and they've given all the numbers and all the performances that they saw on the basic typical benchmark data sets. I think you can go through that. And of course, today, agentic coding and tool use are the most important aspects of large language models. So obviously, this model has also been trained for coding and tool use. And there are also some examples here on this blog where you can directly see how you can just generate a job application web app with just one prompt. So this is Design Arena, and this measures how different models perform with agentic web development. And this, the highlighted ones are the open source ones, and they mentioned that it performs quite well when you consider the open source models. And yeah, if you see, it's also surpassing Claude Opus 4.6. So yeah, so these are all design and web development examples. And the next one is controllable thinking effort, which we will see in more detail when we are trying it out in the workspace. So basically, controllable thinking is nothing but you control how much the model needs to think for a specific problem. There are different levels like low, high, medium, max, and yeah, it depends on the complexity of the problem. Yeah, like I said, multimodality is again a very important aspect, and most models that are being released today are multimodal, which means they support audio, images, and video as well in some cases. So here you can see the numbers on how it performs. Again, they are differentiating between open weights and closed weights. I think the one thing I really liked about this release is that they are very clear about the performance. I mean, they're not advertising this as the best model on the market or the best open weight model on the market, but they're saying it's very close to some of these closed weight and open weight models, and it can also be customized for a specific use case very well. And they are advertising it in a way where they can support the customization as well, which is basically their product. So I think I find that interesting and refreshingly honest, because most releases these days, I mean, even when you open social media, the first thing you see is how every every week some model is released, and you see headlines on social media like Claude is over, and there is the OpenAI is over, Claude is over. So instead of sensational headlines like that, they've been very clear about the model's capabilities. So this is again the full picture of the benchmarks, and they're also divided into different sections, which are very essential for large language models, which is reasoning, agentic coding, and in general how well how well the model performs with agents, and factuality, chatting, and vision, audio. So you can go through these benchmarks, but yeah, you'll really get the feel of the model only when you actually try it, which we will just do in a minute. So these are all the scores and the high level details. There is also a detailed description of the architecture, which is very typical for the model releases these days, which is mixture of experts has become very common. And apart from, they've also used some of their own research they have published in the past, like for manifold research for hyperparameter tuning and searching. And they've also used this different kinds of optimizers. Adam optimizer is the most common one, but Muon is again the new optimizer that has been introduced by Moonshot AI for bigger matrix weights. Since this is like a huge data set, they've trained with 45 trillion tokens. I think a hybrid optimization strategy makes sense. And they've also applied RL at scale. And after applying RL, you can see that the reasoning has improved quite a lot. So you can go through all this in much more detail in this blog. And if you are not aware of some of these terms, I will make sure to discuss them in much more detail, because most releases these days have certain terms like mixture of experts, and also the optimization strategy, the reinforcement learning, the post training techniques that have been used. So these are very common. But when you're choosing a model, or when you're are trying to understand how AI works in depth, I think these are the terms that you should at least have a high level understanding. So I will discuss them in upcoming videos. Next, let's discuss about Inkling Small. Again, it's the age of small models, right? If I mean, deploying a 975 billion parameter model is not a very easy thing, even for a startup or a company. Only bigger companies can afford to do that. But with a small language model, I think you can. Uh, but with a small language model, I think you can still achieve most of the capability for a specific task. The smaller versions of the model, they usually use all the same techniques and also the architecture. The only thing that changes, I think, is the training data that is reduced. So yeah, I mean, if you have training, if you have customized data, I think you can use Inkling Small and then fine tune it. So again, these are all Inkling's benchmarks on how they work. And so they're comparing how Inkling and Inkling Small are differ in terms of benchmarks. So you can see this, and if there's not much of a difference, then you can use the smaller version and save some money and resources. So yeah, they've mentioned it that early results, they show Inkling Small performing very close to Inkling on reasoning and agentic tasks. So if you want to use it for like a simple agent, instead of going for Inkling, which is much more, instead of going for Inkling, you can just go for Inkling Small. So yeah, like I also mentioned, many real world problems are not solved well by even the best generalistic models like closed models. But the gap can be closed by fine tuning, which is what they are highlighting here. And regarding the pricing, they have the pricing very clearly on their pricing tab, which I will just show you. So they've released this. They have a OpenAI compatible API. I think you can use this, and there's a 50% discount going on because it's a new model. So this is the price for 1 million tokens. I mean, they've mentioned that the context window is 1 million tokens, but they are, but I think on the API, only 64K and 256K are available as of now. And there is also a cash-in price. And this, again, the documentation for this is very clear. And we'll also see in the playground how it works. There's also a GitHub repository where if you want to go in detail and fine tune some models, or maybe you can fine tune Inkling Small once it's released. It says it's not been released yet. Well, if you have the resources, you can just directly fine tune Inkling as well. So it's also available as an API on Together AI. Together AI is, it offers an API for accessing all the open source models. So I think it's available on multiple platforms, even on VLLM, and it can also be used with Onslaught for inference in Llama CPP. And it's again available on for Hugging Face. So these are the details about the Inkling models. Now let us go to the playground and try it out and see how it works for different tasks. So this is the Tinker playground. It's a very typical chatbot, but I'm sure it comes with many agentic capabilities. So you can see your track your usage here, and you can add API keys, and there are docs and also the different kinds of projects. And here is the controllable thinking part, if you see. So as of now, Inkling is the only thing, only model choice. But yeah, I think Inkling Small would also be added, and you can also click on this and get some code to get started with the API. So you can, it also mentions how you can do some function calls use. So this is the API code, but for now let's stick to the playground. And there is also this parameter called reasoning effort. Like we have discussed controllable thinking. So you can just mention different levels of reasoning effort. And yeah, for now, because we are trying to generate some UI, I will just make it medium. And maximum tokens is again the maximum response length that will be generated. You can increase it up to 32,000. And the web search, you can enable the web search, but I think for this task UI design, I think it's not necessary. Let's disable it. And the interesting thing is there's also the system prompt, because usually these chat applications, they don't give you the system prompt. But yeah, I think if you want to edit it, you can try it. So you can also try all these things. You can ask it to find the flaw in a proof, or just do something random or surprise you, and also ask it to write code and also pressure test some of your ideas. So there are many things that you can do. So as per what we discussed, I just asked it to design an interactive Cartesian coordinate system. Let me say that it's a web page. Interactive Cartesian coordinate system, which shows a nice bubble whenever the user clicks on it, which is what we saw on the blog. So let's see how it performs. So it's thinking, because thinking is medium and enabled, and you can also see the thought. So what I did was I just copied all this code and I saved it in this interactive webdesign.html file, but it really didn't work. So again, I asked it to see that, I don't see the bubbles. Can you just generate it again? This time it generated it correctly. So I will show you how it looks like. So it's like this. So click anywhere, bubbles appear. So this was the basic prompt that we gave. So let's just click somewhere and see how it works. See? So whenever we click on some place, it shows a bubble. I mean, this is a very basic version of what we saw on that blog. But yeah, my prompt was also basic. So it's nice. So I think the the numbers we saw on the design arena are not all misleading. So this looks nice enough. And if our prompts were more detailed, I'm sure the system would also be more detailed. The code that generated would also be finer. So let's clear chat and now enable web search, and then let's ask it to do some research about women's tennis and also Wimbledon, and come up with some interesting graphs and facts. So I gave my prompt like this to so I gave my prompt like this, asking it to make a very detailed search about women's tennis over the years, and also come up with stats and events, and also make charts whenever it is needed. I think this will actually show the agentic capabilities, because the web search is also enabled, and I'm also asking to come up with facts. So we can test the factual accuracy of this model. And the thinking, I have still made it medium, because again, this is also not a very complex reasoning task. So it's showing us what all it is searching on the web. I think that's a good thing, because we will understand the sources of where the data is coming from. Okay, so here's the deep dive. So this is the historical timeline, and okay, so there is a bar chart about the Grand Slam singles, but yeah, it's very basic. So yeah, it also came up with some stats, and also most of the information seems to be correct, but the graphs, if you see the charts, they're very simple. Yeah, so I think it's good enough because it's acknowledging what it can't do, and it's asking also, would you like me to convert anything into code so that you can generate and render it? So I think that's good enough. So if you see here, I've just asked to explain some important terms of programming in Hindi, and you can see that some terms have been defined like variable, function, and loop. Obviously, the language is very bookish, but I think that is how most language models are. They're not very colloquial, or they don't like really incorporate the language that is usually seen in the spoken area. So yeah, I think it's very similar to other models. And again, I tried Telugu as well. So even in Telugu, it's very similar to how ChatGPT or other models respond. There are a few mistakes, but on the whole, I think it's very similar to the existing capabilities. So once this is done, I also want to check how it will fine tune itself, because if you see in the example that we've seen here, this is the example that they have given for self fine tuning, because this is very interesting because this is a self improving loop. So let's try this out and see how it works, or if it works. Some random task, fine tune yourself to be a model that responds in a very Gen Z slang for whatever prompt is being given. So let's see how it works. Okay, so I think this is the entire workflow that they have included here, and not just the model, because if you see, it's refusing to just fine tune itself, and it cannot fine tune itself because I think it's not connected to the agentic tools that are needed for doing that. So maybe they've put that only for demonstration purposes, and or maybe they will add these agentic capabilities of fine tuning in the upcoming releases. I think that is my best bet. So yeah, now let's see one more example. Let's just increase the reasoning effort to maximum, which is extra high. And so let's increase the reasoning effort to extra high, and let's ask the model to solve the problem of Tower of Hanoi. So here I'm asking the model to solve the Tower of Hanoi problem, and I've raised the reasoning effort to extra high. So Tower of Hanoi, maybe you've already heard of it, but it's a puzzle where there are some n number of discs of different sizes stacked on one peg, and with the largest disk at the bottom and the smallest at the top. So there are three pegs, and the goal is to move all the disks from one peg to the third peg, A to C. So, and there are some rules. Only one disk can be moved at a time, and only the top disk of any peg can be moved. And also, a larger disk will never be placed on top of a smaller one. So, these are some of the requirements. This is a very famous problem, and we want to see how the model solves this problem, and if it will return the correct number of movements that are needed to move the pegs correctly from A to C. Let's see. So it already knows the answer, I guess. So it's just saying 255 moves, because this is the recurrence relation that is necessary in this situation. So let's see. So it's also giving us a very detailed output, like as to how to move from one peg to the other. And it's also doing some web search, which is interesting. I mean, usually when the reasoning is high, the web search, even if it's enabled, usually models don't do it. So yeah, it's interesting that it's not just using its own knowledge, because it had some doubts. It's going on the net and searching for it. So if you see here, it is stored for quite a while because we have added extra high reasoning, and it is giving us a list of all the moves one by one, all the 255 moves, because it is 2 power n minus 1, n here is 8. So it has given us all the moves just like we asked in the same format. So I think extra high reasoning is working quite well, but I have to say it is quite slow. So unless it is absolutely necessary, I think medium or high reasoning will be better for more tasks. These are all the tests we have performed on Inkling. So this is the basic introduction and high level details of Inkling, and there are many other interesting details about it. Like they have also included some benchmarks for forecasting, how the model behaves when it is asked to forecast some future events, and they have done a lot of interesting research in this space, and they have incorporated all their research into these language models. So they have a unique approach of training and deploying the models. So I would dig much deeper into their research and also the forecasting and all the benchmarks in the upcoming videos. And I also plan to make some videos in the space of fine tuning these existing models, especially for Indian languages. So interested in this kind of content, please do subscribe to the channel and also let me know in the comments what kind of topics you would like to watch. Thanks for watching.